The following is presented using funding provided by the Ohio Department of Higher Education to the University of Dayton Center for Cybersecurity and Data Intelligence in its role as Regional Programming Center for the Ohio Cyber Range Institute. The University of Dayton is a top-tier Catholic university dedicated to advancing knowledge, educating future leaders, and serving the common good. The Ohio Cyber Range Institute advances an integrated approach to cybersecurity education, workforce, and economic development in cyber-related fields throughout the state. It is sponsored by the Ohio Department of Higher Education and the Ohio Adjutant General's Department Office of the Ohio National Guard and is headquartered at the University of Cincinnati. The following talk is about blockchain and how it may enhance supply chain security, presented by Major Ben Hazen, Associate Professor of Logistics and Supply Chain Management at the Air Force Institute of Technology.
Hi, my name is Dr. Ben Hazen, and I do research with the Air Force Institute of Technology, mainly in the areas of supply chain management and how technology can use to enhance our supply chain management practices. One of the areas I've been working on with great interest over the last 2 years is the use of blockchain for supply chain management and how that might add trust and security to our supply chains. Now you might be asking, why do we need this trust factor? Why do we need security? Well, let me walk you through a simple example. Now, I'm sure most of you have flown on a plane or helicopter or something throughout your life. And for the most part, we know that these are secure forms of travel. You're probably a lot safer off in that airplane than you are in a car. However, things can still go wrong. And when they go wrong in the air, it's usually not a very good outcome. So consider, for instance, military folks who fly around on helicopters to get from point A to point B. These are everybody from your privates to your generals. And say one day one of these goes down. Now, why did it go down? Well, it's not because of enemy fire. It's not because of adverse conditions or winds. Comes to find out there might have been a counterfeit part. And we're figuring out more and more across airline and across high-tech fields, not just in the military, that counterfeit parts are a real problem. So in the case of the helicopter going down, folks did some investigation and realized that there were some counterfeit parts at play here. So there's potentially an issue with the traffic alert and collision avoidance systems called the TCAS. Or there might have been a problem with the identification of friend or foe system, which pretty much tells other folks flying in the air if this is a good guy or a bad guy and whether or not to engage. Pretty important technologies for aircraft. Come to find out, the FAA, Aviation Safety, provided a notification of unapproved parts on some of these aircraft in terms of the TCAS and the identify friend or foe. And this was in 2012. However, you might think, okay, we found a couple bad parts, we've replaced those, we've gone on. Well, that's not really the case. And actually, over the last couple of years, we're finding more and more instances of counterfeit or otherwise not the proper part being in aircraft and other systems. This 2014 unapproved parts notification from the FAA talked about aircraft engine controls being counterfeit and made by a company that was not authorized to make these. They somehow got into the supply chain and on airplanes. And these are critical components which could easily cause a aircraft to crash. More recently, in 2016, another unapproved parts notification came out from the FAA talking about Intel microprocessors. And they even gave a graphical depiction of what to look for in these certain processors. And usually when this happens, when these types of notifications go out, it means grounding the fleet. It means doing inspections and figuring out if you have the right part or not. So sometimes just figuring out which part is the counterfeit part is very challenging. And then you got to go and find those parts across all your fleet of aircraft. And it's not an easy task to do because we don't track and trace things as well and as securely. So that's where this idea of provenance of products and tracking and tracing those throughout their life cycle and supply chain really comes to fruition and helps us to allay issues caused by counterfeiting and malicious actors. So as discussed in our example, not all parts are created equal, and they're not all equally trustworthy. Some parts are made per spec, some parts are not for one reason or another, whether it comes from the OEM manufacturer, or it comes from a third party or a night shift in an overseas location that's trying to turn an extra profit. So the problem with the counterfeit parts is exacerbated by the fact that our global supply chains are far-reaching and involve many different companies across many different countries. Global supply chains for aircraft entail that there are several different subsidiaries across the globe that are making different parts and pieces that are eventually assembled at one certain area. And keeping track of where those parts and pieces came from, especially for your first tier, second tier, third tier, and beyond suppliers, can be very difficult at times. And not only do we require trust in the aircraft global supply chain, but any product or service that you can really think of that you use, whether that's your smartphone, your laptop computer, the clothes you wear. How do we ensure that they're made with the right products as advertised and they won't cause any type of adverse effect? For instance, it's estimated that in the pharmaceutical industry, there's over 1 million deaths per year across the globe that are attributed to counterfeit medicines. And that's medicines that are strictly maybe made with something poisonous or something harmful, or just the fact that somebody thinks they're getting a medication for, say, their heart or lungs or some other function, and they're not getting the right type of medicine. They're not getting real medicine. Supply chain management professionals are always looking a way to instill trust and trustworthiness in their supply chains and making them well-oiled, and so that everything gets from point A to point B and ultimately satisfies the end customer. So supply chain security aims to improve this integrity of that system. So what is the potential of blockchain to enhance supply chain security? Well, I think we need to begin by saying, what is a blockchain? So a blockchain is essentially, it's a distributed ledger. So instead of a database held on a single server, it's a database held across multiple computers. It's an append-only type of system. So once you go in, once you've transacted recorded data, you can't go and delete it afterwards. And it's also cryptographically secured. In fact, blockchain, as you might know, is the underlying technology enabling cryptocurrency. Blockchain enables Bitcoin, but it's so much more. And a lot of that hype around Bitcoin and then subsequently blockchain has to do with all those price increases you saw, especially in the end of 2017, beginning of 2018, where blockchain or Bitcoin went from being a few dollars per coin to over $20,000 per coin. But again, Bitcoin is not just blockchain, and there are some potentials in cryptocurrency and solving these other problems, but that's not really the focus of this talk today. Instead, we want to talk about what blockchain is and where it is right now and what businesses are doing with it to secure their supply chains. So the consulting firm Gartner creates a hype cycle. And this is their understanding of how technologies work and how technologies come from an initial idea displayed by some sort of technology trigger, some need, some new technology that was discovered, to eventually being some sort of productive technology that's in use across industry. As you can see here, there was a trigger for blockchain a while ago. 2008 is when this whole Bitcoin started, which was, again, the first operational blockchain. And we've kind of traveled up, and we've traveled up to this point of peak inflated expectations where, I know in the last year or two, I've seen articles touting the blockchain and how it's going to solve a multitude of problems across business. And while there are some potentials there, we're not quite there yet. And we're to this point now where we're heading from this inflated expectations into what they call the trough of disillusionment. And that's where companies are realizing, hey, this isn't the panacea maybe we once thought it was. Or, hey, these are some good ideas, but we're far away from having the technologies and the capabilities in place to leverage this technology on a large scale enough basis that's going to be cost effective and actually solve our problems. So right now blockchain is kind of going towards that disillusionment, but there's some hope. There's a plenty of companies out there that are actually using blockchains for a lot of different reasons. And of course, in my area of supply chain security, there's a lot of good exemplars of using this technology to help supply chain trust and to enable transactions and record keeping across organizations, across the supply chain. Right? So eventually, we're seeing here maybe in another 2 years or so, we'll be back on this slope of enlightenment and eventually reach our plateau where this is productive, useful technology. And so what we say to a lot of companies, if you're not one of the big supply chain leaders in your supply chain, you might want to just keep abreast of what's going on with blockchain technology and keep abreast of what your major buyers, your major customers are seeing, because we think that this might roll out sort of akin to Walmart and their rollout of RFID several years ago, where they, in a way, forced their suppliers to use RFID to help them track and trace products. Well, we think the same thing might come to fruition here in the next couple of years, where supply chain leaders will have a blockchain solution, and to be a part of their ecosystem, you're going to want to be well positioned and capable of following through any implementation requirements that might be leveraged upon you. There are several different uses of blockchain for supply chain security, but one that we've been studying the most has been this counterfeit prevention and supply chain transparency, like we talked about earlier. Now, top companies are doing a good job of tracking inside their gates, but the perimeter should be expanded to suppliers and other external partners. And that's where blockchain really has this advantage, because instead of one company keeping the ledger for everybody, or instead of every company across the supply chain keeping their single ledgers, which may or may not actually reflect reality or reflect what their trading partners have recorded, you have a blockchain which really, it's a single database distributed across many other computers. So we all have the same database. We've all agreed through some sort of business rules or processes that a certain transaction took place and it was accurate. And then we've recorded this in a way that is immutable, so no one can delete it. We can go in and perhaps make another block in the blockchain that updates or calls to correction a certain other block. But you're always going to have that information there. And that's a real win when it comes to instilling that trust that your trading partners are going to do what they're supposed to do, what they say they're going to do. And it also holds you accountable in your company for doing what you say you're going to do for your trading partners. So in sum, there's a dire need to increase visibility and transparency across the entire supply chain. So how do we do that? What are some ways which companies are doing that? So I'll go back to another aircraft example about the supply chain, where it's really all about flows, right? We have different companies with different customers. For instance, we have a GE engine that's manufactured by GE, and that goes into a Black Hawk helicopter manufactured by Sikorsky, which at some point in time gets delivered to a military base. And it gets used, it travels wherever it's supposed to travel, it does its job, and then it ends up being in our closed loop supply chain system, meaning it's going to be repaired, maintained, overhauled at certain depot locations, and then also certain areas across the internal supply chain, that closed loop supply chain. And it's going to go round and round and round, keep being reused, then, maintained until it's time to retire that asset. So there's a lot of different transactions taking place in that example. First, you have that transaction between GE and Sikorsky. So there's a record that needs to be kept somewhere in this global database. Then you have from the Sikorsky to the military. And then you also have the military with all its depot and other MRO, maintenance, repair, overhaul, capabilities, where it's going in and out, getting transferred from maybe one installation to another. So that's a pretty complex system. And in the past, each node would maintain some sort of record. They would maintain what they did, where they sold it, and then, or where they transferred it, and then at some point, they're hands off. They're completely hands-off. Hey, that's not a part of us anymore. It's moved on to another company. It's moved on to the military, or it's been retired. Well, that doesn't work when you're talking about provenance and securing the supply chain and making sure that you have the right parts and pieces in place that are manufactured according to regulation, manufactured for airworthiness. So at some point, maybe in the use of that helicopter for a military application, there will be a problem, like we saw here with that TCAS system that needs to be rectified. And so you need to be able to trace back all the different opportunities that system has had, that other people have touched it, or opportunities for counterfeits to be inserted in the supply chain. So that could be all the way back at the manufacturer, where a sub-tier supplier gave them a bad part to begin with. It could be somewhere in the manufacturer, the Sikorsky manufacturing process, where something was left out or made available, or a new part had to be replaced because of a new manufacturing requirement or a need of the military. It could happen on-base military maintenance if you get a bad part from your supply folks, or it can happen in one of these depot or MRO type of facilities where you're really taking down all the aircraft, taking all the skin off, taking them down to their core components and replacing things there. So there's a lot of different opportunities for counterfeits to be inserted in the supply chain. So this is where blockchain helps to keep that record alive and helps to keep that one singular record that, according to your business rules, everybody can have access to. Yeah, so obviously blockchain is going to play a big role. But blockchain isn't the only piece of this puzzle. Because we can put anything we want into that block, we can come to consensus that something happened. But how do we know that that's the actual part or piece that we're tracking? And that's where a similar technology comes into play, where you're going to need something to actually mark the actual item. And this is where there's been a lot of technology stacking for supply chain security, where we might need some sort of unique marking identifier that's going to stay on the product for its entire life cycle. So in this case, we have an example of tuna being tracked from bait to plate, as they say. And as you can see there, there's a little tag affixed to the fish with the QR code, and that's going to follow that fish all the way until the actual packaging processing or whatever is going to happen to the very end of life of this fish. Or let's say it's at a restaurant and it's going to be tracked and traced all the way till the end, so that if we had some sort of recall on fish, we know which ones that we would need to pull, we know which ones would need to be replaced, and we can also go back and find the root cause of whatever issue that was that drove that type of recall. So in the same way, in say an aircraft supply chain, or any other supply chain, we need a way to affix a tag. And so there's a lot of cool innovations going on. There is something with it's actual DNA-based ink. There are nanoparticle inks that are being made for the sole purpose of marking almost invisibly on different products or circuit cards or whatnot that can track something from the provenance where it's confirmed to be of the actual quality and specification through the supply chain. And you can check that at any point through the supply chain because you have your blockchain and then you have the tracking from this special mark. So these are some of the technologies that are out there that are being mixed with blockchain. But the other thing and one of the reasons why we're still kind of going towards that trough of disillusionment is because we don't have the common business rules and common standards applied yet. We haven't come to consensus on that. Now, in terms of transportation, supply chain industry, the Blockchain and Transportation Alliance, BITA, has been dedicated to coming up with the next protocols for mass consumption. Really, if you want to relate it to the internet days, and what made the internet work was having that standard TCP IP protocol. Well, we're still finding our TCP IP for blockchain. Now, in terms of business rules, this is also an area where where different businesses in different parts of the supply chain are trying to come together and figure out, okay, what makes the most sense? Because at some point you're going to have to determine what those consensus mechanisms are going to be. So say in Bitcoin, the consensus mechanism is mining and doing these advanced math problems. Well, as you probably heard, that takes a lot of energy, a lot of time, a lot of computing power, and isn't something we're going to really want to do on a mass scale. Instead, we need to find other types of consensus mechanisms really driven through business rules on when we decide that a transaction happened and was legitimate. And you're going to have to do that with your supply chain partners. And right now, there's companies that are doing this, but there really aren't any established benchmarks or best practices to go from. But that's something we're working on now. Another thing is to determine how you want to drive the network structure. And there's 3 types of network structures. There's a public, a private, and a consortium. In a public structure, kind of like Bitcoin, there's no centralized management. It's permissionless, it's anonymous, and participants could even be malicious. There's consensus mechanisms, like we talked with blockchain or Bitcoin, like proof of work, proof of stake, etc. Large energy consumption, no finality, and you only need to have that 51% to drive that consensus there. So there's some vulnerability to attacks. From a transaction approval frequency, it takes a long time. At the rate Bitcoin is now, it's 10 minutes or more to authorize a transaction. And when you're talking about millions of transactions that happen across the globe on a daily basis, that's way too long. So we got to work that technology too. And then it's definitely disruptive. It's disruptive in the sense of disintermediation. There's no middleman needed, but it's unclear what the business models are going to look like at this time. So the next type is a private, where a single organization kind of holds charge of the ledger. So it's permissioned, which means that only identified and trusted users can view certain parts of the blockchain. So say, for instance, I deal with I have a main supplier that supplies 50% of the things that I need to make my parts in my company. Well, I would give them permission over any records or anything that entails their products that I take on, their use of those products, so on and so forth. But I probably don't want them to have access to what might be one of their competitors, who I also buy from for other pieces. Probably don't want them to have access to all of their information. So we'd permission and parse out exactly what parts of the blockchain we want certain companies, certain partners to use. Now, for consensus, there's a voting or multi-party consensus algorithm, which is lighter, faster, lower energy, and it enables some sort of finality, right? There is an endpoint to it. And transactions, we're talking about 100 times per millisecond. So this is where we're getting into the idea of, okay, this is more workable. Now, and it's cost cutting. It can radically reduce transaction costs, kind of like how SAP did that in the 1990s. However, you're starting to lose some of the benefits of blockchain, some of that immutability, and some of that sharingness when you have a single organization in charge of the blockchain and only given permissions as they deem fit. And say you have a very complex supply chain where there's a couple of large companies, say GE and Sikorsky, who's really going to own that blockchain? Who's going to give permissions to who? So that's a problem that's still open right now. The third model is a consortium. So it's multiple organizations across the supply chain. It's permissioned, just like a private one, where it's you only have identified and trusted partners. You still have the same type of consensus mechanisms. It still gives you that transaction approval frequency that we're looking for. So in a sense, this idea of the consortium is where a lot of current researchers and business leaders are getting together to kind of figure out where these best practices might be. Because obviously the single one isn't going to work too well. The public one with absolute, too much out there might not work too well. So there's going to be something in the middle in this consortium. And again, that's where research is heading. That's where we're kind of focused on now, trying to define what that means. So to summarize what blockchain is, it's a distributed, immutable, cryptographically secured database structure that's tailorable to the goals of the network. Big takeaways: it's an emerging and growing technology. We have a long way to go. We have to do a little better with our transaction time. We have to do a little better with having the right hardware available. And we have to do, and we're still working on figuring out the right type of markings to use in conjunction with blockchain for each and every specific instance and type of product. As you can imagine, what's going to work to mark a loaf of bread is not going to work the same to mark some grapes, and it's not going to work the same to mark aircraft parts or fish. So we need different options and different opportunities and better understanding of what those mixes are of that technology stack and what else they do for your supply chain and for your technology roadmap for your company. Also, it's way more than just a cryptocurrency. Obviously, some of the major initial hype around blockchain has been with Bitcoin and Ethereum and all the other cryptocurrencies and ideas that have been generated therefrom. But the idea of a blockchain itself is just that enabling technology, and it can be applied well outside of financial instruments. And of course, like any technology that we study, it's not a panacea solution, but offers interesting potential. Most of the technology experts I talk to find that there is some good use of blockchain for supply chain. And there are some companies and some CEOs I talk to that are using it and having success with it. But what it really means on the broader scale and what exactly are all the different potential opportunities, well, the jury's still out on that. So in a sense, blockchain is a solution, platform, and type must be tailored to the problem. Now, finally, I'll leave you with, if you didn't get enough information about blockchain and blockchain uses for supply chain and supply chain security, I'll direct you to a demonstration that we've put together. We being the Air Force Institute of Technology in conjunction with Secure Marking, who is a purveyor of secure marks that they're using with blockchain and with other database type of technologies. If you go to the website, you'll see that there are some links to some videos that Mr. Daniel Stanton, also known as the alias Mr. Supply Chain, has put together to describe more about blockchain and blockchain for supply chain security, and then also a running demonstration where you can put through and you can create real blocks to go in a real blockchain and show how parts and pieces move throughout our notional military supply chain. With about 30-40 minutes of your time and attention, I think you'll have a really good understanding of what this phenomena is and what it might mean for the future. So thank you for watching this video. Once again, my name is Dr. Ben Hazen, and I would be happy to take any other questions, comments, or concerns you might have at my email address, which will also be posted on the site. So thank you.
If you are interested in learning more about this content, please contact the UD Center for Cybersecurity and Data Intelligence by email at udaytoncyber@udayton.edu, and we will forward your interest to the speaker.